Today, we will start our journey into quantitative research. And today, we will explore some of the main concepts that you need to know in order to better understand quantitative research and obviously being able to consume the literature in a more comprehensive way. So let's start. Here I have on screen some of the concepts for you. So after today, it will be optimal if you are able to say what is the difference between an independent variable, a predictor variable, a dependent variable, an outcome variable, a moderator variable, a mediator variable. So we have all these different kind of variables. What is a variable? So we will see about that today. And then it will be important for you to know about null hypothesis significant testing. What is the null hypothesis? What is the alternative hypothesis? What kind of errors we can make when we are testing this hypothesis? And about statistical significance, the alpha levels and the p-values. So as you can see, now we are going slowly going into statistical analysis. Obviously, I will try to simplify the terms, and I will try to be straightforward. Let me know if something else is missing in my explanation, but it's really important that after today you are familiarized with these concepts, okay? So let's start talking about quantitative research. As we already discussed in previous sessions, quantitative research focus on gathering numerical data in order to make generalizations across groups of people or to explain a particular phenomena. So generalization is very important for quantitative research, and this is why the methods are standardized. And we are making an operationalization of the construct that we want to measure, because we want to replicate the findings of our research, which is different for qualitative research. So here you have on screen some of the main characteristics of quantitative research. So the data is usually gathered using structured research instruments, and the results are based on larger sample because we want the sample to be representative of the whole population. So this is why you need larger samples, and most of the statistical analysis needs larger samples in order to be powerful enough to detect the differences between two groups or the influence of one variable in another variable. So this is all about larger samples. Also, the research study can usually be replicated or being repeated because of the systematicity that I was telling you before. And all aspects of the study should be carefully designed before data is collected. And this is very important in quantitative research. And I will ask you to always, every time that you are reading a paper in psychology, before they start with the method section, just before the paragraph before that should be about the hypothesis. They should tell you what are the hypotheses they are testing. If it's an exploratory hypothesis, then they may not have one. But if it's a correlational one, or they are trying to establish causality, they have to tell you the hypothesis, because you need to know explicitly what are they trying to test. If they are not giving you this information, then from the beginning, you know something is fishy in this kind of reporting about this study. Okay, so the data that we use in quantitative research is usually in the form of numbers, and we run statistical analysis in order to make conclusions about the data. And often we arrange this information in tables, charts, figures, or we also have non-textual forms to present this information. Through the course, I will try to show you, and I will ask Farhud also to show you some of the main charts that we use in psychology in order for you to be able to better understand the next time that you are seeing this chart when you are reading papers from psychology. And the study should be used to predict future results or to investigate causal relationship between variables. So you need to have an hypothesis. This hypothesis needs to be testable, and this is a key element in quantitative research. This is also tied with having a precisely formulated research hypothesis that will undergo rigorous testing. So these are the main characteristics of quantitative research. And regarding the questions that you can answer with quantitative research, as I already told you last session, we have 3 different kinds of scope in research. Either you are using the qualitative approach or the quantitative approach. You can have exploratory research, descriptive research, and explanatory research. So, for example, the kind of questions that you could ask if you want to run a quantitative exploratory research are, for example, what factors influence the removal of children in child welfare cases, for example. So you are just asking in general, what are the factors that are involved there? You don't know the factors. This is why it's exploratory. And then you can have a descriptive study, for example. In this case, the question could be, what is the relationship between maladaptive coping strategies and homelessness, for example, in late adolescence in foster care? So this is a correlational hypothesis. So in this case, we do have a hypothesis. In the exploratory, we don't have one because we don't know the factors. And if you want to go and establish cause and effect relationship between 2 variables, then you need to run an exploratory study. And one question, for example, could be to explain how race impact, how does race impact rates on mental health diagnostic for children in foster care. So these are the different questions that you can ask and you can answer with quantitative research. So don't forget about this scope. It's really important for you to know which one of these will you choose for your study. So let's now dive into the specific concepts that I want you to grasp today. So let's talk about variables. So a variable, as the name can indicate, is any characteristic that can be measured and can vary from one observation to another. This is why we call them variables, and we have many different kinds of variables. Generally speaking, we have 2 main different kind of variables. We have conceptual variables and measure variables. The conceptual variables are abstract ideas that form the basis for research hypotheses. For example, abstract variables are gender, age, anxiety, coping strategies, depression. All of these are conceptual variables. So it's just an abstract idea. And then you need to determine how to measure this abstract concept, how can be measured. And then you will end up with measure variables, which consist in numbers that can represent the conceptual variables. To turn from conceptual variables into measure variables, we call this process operationalization. So here we have an example of, for example, this concept, social anxiety. So social anxiety, for example, we can define it as sentiments of fear and anxiety in social situation, causing considerable distress and impairing ability to function in at least some aspect of daily life. So this is the abstract variable, the conceptual variable, right? And how can we measure it? So how are we actually operationalizing this conceptual variable? We need to determine. We need to know how we can turn from these concepts into specific indicators that we can measure. For example, for social anxiety, we can have, for example, we can assess people's perceptions, or we can assess the behavioral avoidance in crowded places, or the physical symptoms they display when they are in social situations. So as you can see here, we have different methods. In order to assess the perceptions, we can use self-reports, questionnaires. In order to assess behavioral avoidance, obviously observation will be the method. And the method that we'll use in order to explore physical symptoms are physiological measures. So my recommendations will be to use different methods in order to assess the same construct, in order for you to be sure that you are assessing the abstract concept that you are trying to grasp, okay? So the way it works in psychology is first with an abstract concept, like let's say psychological flexibility. This could be another one. First, we need to determine what it is, so the concept, and then we have to determine how can we measure it. And once we develop this measure, and we have to establish, obviously, the validity and reliability of this measure, but then you need to test it to see if you are correct transforming this conceptual variable into measure variable. And how are you testing them? By predicting behavior in a specific condition. This is the way it works in psychological science. So now going deeper into the different kind of variables, here you have, I will say, a really simple explanation of what kind of variables do we have in psychology and how we use them. So really important for you to know the independent variable. It is a variable that stands alone and isn't changed by any other variable. This is why we call it independent. So the opposite of this variable will be the dependent variable, which will depend on the independent variable on the changes that we make in the independent variable, and we will see changes in the dependent variable. So as you can see here in the chart, so the independent variable happens by itself, and then the dependent variable is the one that we are interested, and we know that somehow the independent variable is making a change in the dependent variable. So these variables are also known as predictor variable. This is the predictor variable, and this is the outcome variable when you are using inferential statistics. This is when you are trying to assess the probability for these results to happen, and then you are using a statistical test in order to see if your hypothesis of the influence of one variable in the other is true or not. Then these variables are called predictor variable and outcome variable, okay? We also have very important moderator variables and mediator variables. So as you can see here in the chart, so a change, we are predicting a change in the dependent variable, right? But we don't know what is causing the change. What underlying mechanism is happening in order for this variable to make a change in the dependent variable. So this underlying process explaining why it happens, this is the mediator variable. And the moderator variable, it's just telling you about the strength or the direction of the influence that you have of the independent variable into the dependent variable. So the mediator variable will explain why the change is happening, but the moderator variable can only tell you about the conditions in which the effect that you are observing is stronger or weaker. Okay? This is very important for you to understand a little bit more. Let's see this example. For example, we can assume that going like having psychotherapy will decrease the levels of anxiety, right, that are experienced by someone. So we are expecting the more psychotherapy you have, maybe the less anxiety you will experience. So in this case, we know how to measure, like psychotherapy, we can say the number of sessions, for example. This could be the way to measure this. And anxiety, we can measure it with a specific scale that is already validated. For example, the Hamilton anxiety scale, we could use that. But then imagine that we are in fact observing this phenomena that we are predicting. Our hypothesis is being confirmed, but we don't know if the reductions on anxiety may depend on, for example, social support. Maybe some people, they have a big network and a lot of people is helping them, and this is why the anxiety is being reduced. So this could be, for example, a moderator variable. So it is changing the strength of the effect that you are observing. However, it doesn't explain why going into psychotherapy could actually reduce the levels of anxiety. So we could make an hypothesis and we could say that maybe it is self-efficacy. Maybe talking with your therapist it is making you realize some specific tools that you have, and you are increasing your self-efficacy, and then you feel more prepared to confront stress, and then you are reducing your anxiety. So in this case, self-efficacy will be a mediator variable, because is with the me through this variable is that we are actually observing the change in the dependent variable. So this kind of thinking is very important in quantitative research. And actually, this chart that I have for you, this graph, this image that I have for you right now, we can actually turn it into a statistical model, and we can taste it. We can test it. So it is very important for you to understand how the variables can be represented, how they are connected one and the other, and then we can run statistical analysis doing these statistical models. This is why it's important for you to understand how we can depict the relationship between these variables and what kind of influence they have between them. Okay, so this is all about the different kind of variables that we have in quantitative research. Now let's talk about the research hypothesis. Well, as you can obviously imagine, an hypothesis is a specific, clear, and testable proposition or predictive statement about the relationship between two variables. And it is like, for example, we can make this hypothesis that we just made, attending to psychotherapy would lead to decrease anxiety levels in individuals when they are facing adverse events. For example, we can have this kind of hypothesis. And we actually, the hypothesis, we can have a directional hypothesis or a non-directional hypothesis. This is another important distinction for you to make. When we have a directional hypothesis, it means that we are being specific regarding the direction that we are expecting the findings to be. Okay? For example, when we know that going to psychotherapy will decrease the levels of anxiety. So we are already stating that it will decrease, so we know the direction. It will be different, for example, if you only state that attending to psychotherapy will influence the levels of anxiety. In this case, you are not saying if it will increase it or decrease it. And actually, in this specific example, both things can happen, right? Sometimes a lot of people get a lot of anxiety going to psychotherapy because they are realizing things that can be really distressful. So in this case, we will have a non-directional hypothesis. It's important for you to start understanding these kind of concepts, and hypotheses are really, really important in quantitative research because the main statistical analysis that we run in quantitative research is null hypothesis significant testing. And this is the way we have in psychological science in order to be able to prove an effect of one variable on another variable. And for that, we always test the null hypothesis. What is the null hypothesis? Well, the null hypothesis is the one that is stating that no statistical significance exists between two variables or between the means of two groups. So we are always testing this by default, and this null hypothesis that is expressed in this way, H0, it will serve as the default position until the evidence that we have in our data indicates otherwise. So all the time, every time, we are testing the null hypothesis. So we have the opposite of the null hypothesis will be the alternative hypothesis. In the alternative hypothesis, we are stating that we can find actually an statistical significance difference between two variables. So you do see an effect of one variable and in the other one, and this difference is statistically significant. Now, what do we mean? What do we mean with statistical significant? Let's explore an example. Let's say that we are actually running this study regarding attending psychotherapy and then assessing the levels of anxiety. And let's see that we are testing 10 participants, and we are observing that, let's say we have a control group. So we have 10 participants attending to psychotherapy, and we have another 10 people that are not attending to psychotherapy. And then we measure the 20 participants after, let's say, 5 weeks or 10 weeks. And then we find that people that is attending psychotherapy actually show 10% less anxiety that in baseline, that at the beginning. So we are seeing that people, in fact, they have less anxiety. So we don't know if this amount of a decrease is enough to be significant. Maybe it can be, maybe these people, they have specific psychological tools that just by passing the time, even without going to psychotherapy, they will show more or less the same improvement. So in order to know if this finding is actually significant or not, if it was due to a specific thing in our sample and it is just random that we are getting this different, then we are running this significance test. So we don't know when we run this null hypothesis significant test, we don't know, even though we get a value that is small enough for us to consider it significant, we don't know if the finding we are seeing in the data is actually important or if it means something. By testing the significance, we only can know that a result as extreme as the one we are observing in our data, it is not due by chance. This is the only thing that significant testing is assessing. So, for example, here, explaining a little bit more about null hypothesis significant testing. Well, these kind of tests are analyses performed in a statistical sample in order to make a decision regarding the null hypothesis, and the different type of tests that we have are, for example, t-test, c-test, t-test, ANOVA, chi-square, for example. We have more than these. These are the ones that are commonly used. And the use, like the selection of one or the other, will depend on the nature of your data and on your research question. Also in the kind of assumptions made by each one of these tests. So you can run any of these tests in order to explore the relationship between your variables. And then after you perform this statistical test, you have to be careful because we can find two different kinds of error when we are testing this hypothesis. We call a type 1 error when the sample results reject the null hypothesis despite of being true. We call this false positive. Is when you believe you have a significant finding and you don't have anything. So it is just due to random chance and you weren't able to identify it properly. So this is called false positive. And we can have the opposite. We can have a type 2 error that occurs when the null hypothesis is not rejected when it is false. And we call this a false negative. This means in your study, you had something that was significant and you weren't unable to detect it. And then you are accepting the null hypothesis. You are saying there is no significant difference, but you are wrong. And we call this a false negative, okay? So it is very important for you to start making a distinction between these concepts and start grasping how important is hypothesis testing. And here we will talk now about this very important aspect in the quantitative approach, and it is about the p-value. So the p-value is actually the statistic that we are calculating when we are running the null hypothesis significant test. This is the result that we will obtain. And the p-value is giving you the measure of the probability of obtaining an effect as extreme as the one your sample data is showing you, assuming the null hypothesis is true. So this concept is really, really important for you to understand. And maybe you already know that a small p-value is often used to prove that the null hypothesis is not true, and then we have to accept the alternative hypothesis because the result that we are seeing is so extreme that it is unlikely that we see it if the null hypothesis is true. So basically here in this chart, we have we have a sample distribution. Usually, we will talk about this, a normality distribution, the bell shape. Here, when we see our course in descriptive statistics, we will talk a little bit more about how to plot a normality curve. But here, it is important for you to know already that most of the observation will fall into this space. And the extreme scenarios are here and here. And then we are establishing a critical value that is a convention in each field. For example, in psychology, the convention for a critical value is 0.05. And here, if we are reaching this critical value and our observation is as extreme as here, then we can reject the null hypothesis. And we are saying, our data is showing us that a result like this is so rare that is unlikely the null hypothesis is true. So this is what a p-value can tell us. And this is why it's important for you to know, because a lot of people often assume that the p-value is just the probability of the result that you are observing being by chance. And it is not like this. It is a little bit more complex than this. Actually, because a lot of people often misunderstand how p-value works. P-values are often misused and even abused. So this is why you have to know what a p-value is telling you and what a p-value is not telling you. So let me go to an example. If you are reading a paper and they are trying to observe the relationship between two variables and they are running a Pearson test, and they are telling you that the correlation between these two variables was significant because the p-value they found was less than 0.05, which is the standard in psychology. And then they say, okay, our study is working, our hypothesis was proved, and we are able to publish this result because we have significant a significant finding. So this is one of the issues that we can encounter a lot in research in psychology. So the p-value will help you to evaluate the evidence you have against the null hypothesis, but it won't tell you anything about the alternative hypothesis. With the p-value, you are able to reject the null hypothesis. So you have enough information to say that it's probably not true, that you don't have any effect between the two variables, but you are not able to say the opposite, that the alternative hypothesis is true, because you are not testing the alternative hypothesis. You have to run different analysis in order to be able to say that. And this is very important for you to understand, not only because they are finding a p-value that is below the threshold. This value means that the hypothesis is corroborated, the alternative hypothesis, okay? So also very important for you to know, this p-value, also known as alpha level, is a convention and it is different in each field. For example, in medicine, the threshold is 0.01. And in psychology, the threshold usually is 0.05. 0.05 means that we have 5% possibilities that the effect that we are seeing in our sample is only due to chance. So what is the meaning of this? That if you are running 20 experiments and you are getting this result, at least one of them, you will obtain it just by chance. So there is nothing there, and it's just by chance that you are finding this result. So this is why you need to know what can a p-value tell you and how can people misuse a p-value. If a researcher is giving a great emphasis only because they found a p-value that is below the threshold established in their field, and they are ignoring effect sizes, or they are selectively reporting the kind of results where they are finding significance and not reporting the other ones, which is also called cherry picking, then you are abusing p-values, because maybe you are running 10 analyses with like 10 different relationships, and then you didn't find anything in 9 that you have this hypothesis, and all of them failed, and you find one p-value that was below the threshold, and then you are reporting this one and not reporting the other one. So obviously this is biasing the results, and this is a way how you can misuse p-values. And then here, another thing that is really, really important, as I already told you, one thing is to know if the result we are observing can be by chance or not. Is it just by the means of the characteristics of our sample, or is it actually because something is happening in the interaction of these variables? So this is one thing to know. And the other thing is how strong is the influence of one variable in the other variable. So we may see an effect that is too low to be significant and like to mean anything important. Maybe in the example that I just gave you with the psychotherapy, maybe 10% of decrease in anxiety, maybe it means nothing. Maybe just like the pass of time will help you reduce your anxiety without the psychotherapy having any influence. So you don't know. This will depend on how strong is your effect of your independent variable in your dependent variable. So this is a different thing. One thing is the p-value, which can be and should be below 0.05 in order to be considered significant in psychology. And another thing is how strong is the effect. So you can have a result that is not due by chance, but is insignificant, okay? And you can have a result that is not due by chance and is really significant. It means something because the effect is really large. For this, you need to run different statistics. For this, you need to know, for example, the effect sizes. You need to know estimator values. You need to know you need to have intervals, confidence intervals, in order to know where to place your finding. And you need to know all of this information along with your p-value in order to make a strong claim regarding your alternative hypothesis. which is a different thing that we just saw with the null hypothesis significant testing, okay? So now, what is the abuse that we can see with p-values? As I told you in the previous session, so we can have a p-hacking, which is manipulating your data selection or your data analysis in order to achieve p-values that are significant. A really easy example that I can give you about p-hacking is, for example, you have your hypothesis in advance, and then you are running your analysis, and then you are finding that your p-value is 0.06, for example. So it's just about the threshold. So you are thinking, maybe there is an effect there, but I'm not able to detect it because my sample is not large enough. Maybe if I test 10 more participants, I will be able to better detect the effect. So this is a way of doing p-hacking, because just by adding data and then running the test again, you will reduce the p-values just by that. It doesn't have to do with the effect. It just has to do with you repeating the same test because it's a probabilistic test. So this is a way in which you can be p-hacking. So you can be p-hacking without even knowing that you are biasing your results. Okay? Also, really important, and this can also happen to novel researchers, ignoring the assumptions that are made by the test. Then you are running a specific statistical test, like, for example, a correlation or an ANOVA, but you don't know if your data is actually meeting the assumptions needed in order to run that test. And if you are not meeting those assumptions, all the results that you will get won't be valid. But if you don't know this information, you won't know, right? And you will only be reporting. For example, many of the inferential tests make the assumption of normality. So we have a normal distribution of all our data. We will see more about this in our descriptive statistic session. But a lot of research out there, they don't test for normality in the data. And if they are not testing and reporting normality, then they are using the statistical test in order to test the null hypothesis, but they are doing it improperly because the assumptions are not met. So this is really important for you to know in order to weight the conclusions that the paper you are reading is making. So this is a way to use p-value. So just to take away, I want to make an emphasis, so you are able to know that the p-values are not able to tell you what is happening with your research hypothesis. The p-value will only give you information in order to accept or reject your null hypothesis, but it doesn't say anything about your alternative hypothesis. This is really important for you to know. And another really important thing is that statistical significance doesn't imply importance of the finding or any practical significance of this finding. If you have a small effect size, it may mean nothing, even though if it's statistically significant, but is not strong enough to mean anything in a practical way. So it doesn't say anything about the importance. This is why when you are reading a paper in psychology, yes, you need to see the p-value to see the probability that this result that they are reporting will happen if the null hypothesis is true. So how extreme is this value and how rare it is? And now that you know how rare it is, this is some information that you have in order to weight the results, then you need to see how strong is the effect they are reporting, which is a complete different thing. This is why you need to know how to make sense of effect sizes, confidence interval, and other kind of statistics that I will describe in future sessions. So hopefully this was meaningful for you, and I really hope that you were able to grasp this information, because this information is key and it will be all around any quantitative paper. So as closing remarks, let's say about quantitative research that the strengths that we find in this kind of approach is that it will allow for a broader study involving a greater number of subjects and enhancing the generalization of the results. This is a plus. Then it will allow for greater objectivity and accuracy of the results because of the operationalization, the reliability and validity of the tests that you are using. All of these things you need to carry on your research, and we will talk more about it our next session. And because of this structured process that is a bit unflexible, then you are able to better replicate the findings that you are reporting. So it is also very useful, this approach, in order to summarize vast sources of information in order to make comparisons across categories and over time. So these are the strengths of quantitative methods. And what about the limitations? As you can imagine, some of the limitations are that the rigor and objectivity also implies an inflexible process of discovery that can miss contextual detail, and this is where qualitative research will kick in. And the development of standard questions by researcher can lead to a structural bias, as we saw already, and false representations of the results. Also, researchers may collect just a narrow and superficial data set. Maybe your sample wasn't correctly picked, and maybe it was too small in order to be able to make these categorizations. So these are the risks that you have. And another thing that is really important for you to consider is because of the control that you were trying to have within your experiment. So maybe your research was carried out in an environment that was not natural and was artificial. And this is why the effect that you are seeing is actually just an artifact of this unnatural situation and not what you will really find. So these are the limitations that we have in quantitative methods. So just for you to remember the main concepts that you need to take home today, I have it here once again. Now you should know the difference between an independent variable, a dependent variable, a moderator variable, a mediator variable, a null hypothesis, an alternative hypothesis, a type 1 error, a type 2 error, what is statistical significance, what is the alpha levels, and what are p-values. So I wanted to leave you with this screen before going into discussion, because if something is not clear, we can discuss a little bit more about it. So, thank you. Do we have a question? How do you feel about these statistical terms? Are they too much, or were they easy today? Yeah, last cohort, when we go into statistical analysis and we were seeing descriptive statistic, inferential statistics, and we were talking about the test, it was a little bit too much. So in this cohort, we will try to simplify it even more. As you can imagine, you can take statistics for 5 years in order to understand properly how these tests work. But this doesn't mean that you cannot learn about p-values and how they are used and misused, and you can use this knowledge in order to better consume research in psychology. And this is the important part. So was it clear about the p-values? What do you think?
Yeah, I definitely think it's a bite size, even for someone like me who is not exactly a math genius. So it's helping a lot. Thank you.
Yeah, that's good to know, Moritz. Thank you. I don't want to overwhelm you. Well, in two sessions, we will start with descriptive statistics, and then we will start talking about mean, median, and kurtosis and skewness. So it will get a little bit more deeper into stats, but hopefully I will try to relate it always to something that will be meaningful for you in the way you are reading papers in psychology. So I want you to know, to have a big picture of how this methodology works and how we use it, why we use it, and what is actually telling us. So it's just about this. And can I ask about your experience with p-values? Did you know about them before today? Have you used them? What do you think about them?
Well, I think the only place I've heard about them generally is here. Like we've heard about them before here, but occasionally I would get, I mean, I know about statistical significance, right? But I don't know, like I didn't really understand how the p-value relates to statistical significance and stuff. So this is helpful, I think.
Yeah, that's good to know. And for me, it's really, really important for you to be able to tell that not just because the p-value is below the threshold within the field, which is 0.05 in psychology, it doesn't mean that just because it's below, this research is good, or the claim they are making regarding the correlation is good enough. Actually, in some other sessions, I will ask you to read specific papers where they will be reporting correlations, and then you will be able to notice that they are reporting p-values that are significant, but then the effect of the relationship is just too low. It's too low that it's not important. So it's actually a not important finding, and they at the end are making a big leap, are taking a big leap, saying they were able to prove the hypothesis they had. And this information is obviously they don't have the statistical test in order to back up that kind of claims. And this is the kind of things that I would like you to identify in the papers. I would like you to know, they are giving me this p-value, but the effect size is too low. So I don't think the evidence for their alternative hypothesis is strong enough. And then you have your own opinion. This is why I would like you to start noticing these numbers, the effect sizes, the interval, the confidence interval, these kind of things, for you to know better how to interpret the results that the researchers are giving you. Because usually they believe, no, if someone is not knowledgeable in statistics, they won't understand anything of the statistics we are reporting, and then we'll just go to our conclusions, and then they will be left with that information. And then their own conclusions in the paper are not backed up by their stats, right? So I would like you to be able to identify this kind of bias that we have in research. And this is why I'm giving you these concepts right now. So p-value is really important one. Please keep it in mind. When we talk about sample size, power, statistical power, and effect sizes, we will return to p-values. So p-values will be all around the whole course. So I left you in the Moodle platform, I left you a link for a website. Let me show you this website. Let me see if I can share it with, let's see, share the screen. And then let's go to Chrome. Okay, here, I really like this website. It's from the National Library of Medicine. And here you can have like a really easygoing overview regarding the common terms that we use in statistics. So here, for example, they are talking about sampling, and they are also describing some sample methods, some usual errors. They are also talking about what is a dependent variable, an independent variable. They also have an explanation regarding a correlation. What is a correlation? What kind of tests you can run in order to establish the relationship between two variables. So here they talk about validity. For example, this is our next session: internal validity, external validity. So this website here, you can learn a little bit about Z-score, t-tests, p-values. So if you have the chance, go and take a look at this link, and you will start familiarizing with these constructs or concepts. And the next time that we are discussing it in the session, you will be able to better identify the kind of information that you need to always keep in mind in order to better assess how we conduct research in psychology. Okay, so do we have a question, a comment, or are we ready for the weekend? Yeah, we are ready for the weekend. Okay, so it was really nice seeing you today. Enjoy your weekend. Bye.